Oxidation reduction or redox reactions have two parts to them that are occurring at the same time. There's an oxidation part where electrons are given away or lost, and there's a reduction part where electrons are gained in the process. So because the electrons are the unseen components in the redox reaction, notice in the molecular equation there's no indication that there is an electron exchange. We don't really see them, but we can tell because we start looking at the charges, and originally the sodium has no charge and the chlorine has no charge because it is in its elemental state. And then on the sodium chloride side, the sodium ion has the +1 charge and the chloride ion has the -1 charge. The sodium ion lost 1 electron to become positively charged, and the chlorine atom gained 1 electron to become negatively charged chloride ion. And if we split this reaction up into two parts, we call those half reactions. Now, whenever we experience a situation where an atom loses an electron, we call that oxidation, and whenever it gains an electron, it's called reduction. So on a whole, we would say sodium gets oxidized and chlorine is reduced in this chemical process. And notice the oxidized and reduced terms always apply to the reactants and not the products in a chemical reaction or equation. Another way of looking at this is from a different perspective of, is this a reducing agent or an oxidizing agent? And one of the analogies I like to use is the concept of doing laundry. So in that case, we have dirty clothes and we have clean soap and water. And in the process of doing the laundry, the dirty clothes get cleaned and the soap and water get dirty. Now, if I were to ask you what's the cleaning agent, you wouldn't say it's the dirty clothes. It's the clean soap and water, even though the clean soap and water starts clean and ends up dirty. It is the cleaning agent in the process because it sacrifices its cleaning power and it becomes dirty in the process. And the same thing goes with the other respect. So here, whichever one is oxidized is going to act as the reducing agent for the other one. Just like in the previous analogy, the soap is used to clean the water, to clean the clothes. And as such, the soap, while it does the cleaning, it gets dirty. In chemical reactions where the electron isn't exchanged, because we talk about the preparation of a molecular compound where we don't have ions. In these cases, we follow the oxidation number changes. And in this case, hydrogen, because it is in its elemental form, has an oxidation number of 0, and chlorine, because it is in its elemental form, has an oxidation number of 0. The resulting hydrochloric acid gas then has hydrogen with a +1 oxidation number and chloride with a -1 oxidation number. Now, fun fact about this chemical equation, it represents a chemical reaction that can be light activated. And if you would like to, you can look it up on YouTube. There are a couple demonstrations of this reaction where they take a tube and mix hydrogen and chlorine gas in there, and depending on the color of the light that they shine on it, the reaction will explode. It's very cool. All right, so when talking about the formation of molecular compounds, we always have to mention the oxidation numbers. And so if we see an increase in oxidation numbers, we will call it oxidation. If we see a decrease in oxidation numbers, we call it reduction. So I kind of like to replace the decrease in with reduction. If we reduce the oxidation number, then we see a reduction. Now, this is where we see a redox reaction separated in its two half reactions. And we're looking at some ions, so let's look at the oxidation numbers. Iodide has a -1 oxidation number here, and iodine, because it is iodine in its elemental form, it will have an oxidation number of 0. If it goes from -1 to 0, then the oxidation number has increased. From -1 to 0, the oxidation number increased, so this is the oxidation process. And in the second case, hydrogen starts with a +1 oxidation number and ends up with a 0 oxidation number due to it being in the elemental state. So if we go from +1 to 0, then we've reduced the oxidation number and we're looking at reduction. So then we're going to say iodide was oxidized and water was reduced. And that makes B our correct answer. The reducing agents and oxidizing agents, as before, are going to be interpreted as the opposite of what happened. So whichever one got reduced, it's the oxidizing agent. Whichever one got oxidized is the reducing agent. The agents are what's causing the process to occur to the other component in the chemical equation. So if we are to put this together and attach it to a chemical equation, this is what it would look like. Iron goes from the 0 oxidation state to the +3. And in this process, it gets oxidized. Because iron is oxidized, it will be the reducing agent for the oxygen. Oxygen goes from the 0 oxidation state to the -2. The oxidation number is reduced from 0 to -2, so this is a reduction process. And because oxygen was reduced, it will be the oxidizing agent of the chemical equation. Now, the reason why the term oxidizing agent was introduced is because normally the oxidizing agent is either oxygen or some kind of oxygen-containing compound. And we're going to see the exact same setup. Here, iron starts out in the +3 oxidation state, which then gets reduced to 0 by forming elemental iron. This is a reduction, and if iron from the 3+ oxidation state is reduced to 0, it will act as the oxidizing agent. And notice what I said before, the oxidizing agent typically is oxygen or some kind of oxygen-containing material. Carbon in this reaction is oxidized from the 0 to the +4 oxidation number, and as it is oxidized, it will act as the reducing agent of the reaction. In these chemical equations, we're going to determine the oxidized and reduced species, and we're going to look at the different agents here. Let's start with identifying the oxidation numbers. For the tin 4 ion, the oxidation number is the charge, so that's a +4. For calcium, because it is in its elemental state, the oxidation number is 0. And on the other side, the oxidation number is the same as the charge, so it's +2 for both. Tin goes from +4 to +2, the oxidation number is reduced, so we're talking about a reduction here. And whichever one is reduced is the oxidizing agent. In the case of calcium, calcium goes from the 0 to the +2 oxidation state. Because the oxidation number increased, we're going to say it is oxidized. And that means calcium is the reducing agent. We can do the same thing for the next chemical equation. Fluorine is in its elemental form, so the oxidation number is 0. Sulfur is in its elemental form, so oxidation number is 0. And on the product side, fluoride is going to have an oxidation number of -1. And because there are 4 -1 oxidation numbers, sulfur has to be +4. Fluorine goes from 0 to -1. The oxidation number is reduced, so fluorine is reduced in this process. Therefore, fluorine is the oxidizing agent. Sulfur goes from 0 to +4. It is oxidized, and if it oxidized, then sulfur is the reducing agent. Fairly straightforward. Once you establish the oxidation numbers, it's just a matter of looking at, is it increasing or decreasing in the course of the chemical reaction. In this problem, we need to identify the oxidizing agent. And I could tell you just by looking at it which one it is. How? Well, it's fairly straightforward. The oxidizing agent has to be on the reactant side, so I have to look on this side. And if I look on that side and I remember that oxidizing agents typically contain oxygen, then I can say without a doubt that it's going to be the permanganate, and I would pick option A. Now, going through the rigorous process, I can do that. In the case of the potassium permanganate, I can check the oxidation number of both ingredients. Oxygen has a -2 oxidation number, and if I were to calculate the oxidation number of manganese, it would be +7. On the reactant side, manganese has an oxidation number of +7. On the product side, it has an oxidation number of +2, so manganese got reduced, and if it got reduced, it's going to be the oxidizing agent of the chemical process. In this case, it's simply a matter of doing the same process as before. And just like before, I can tell you without a shadow of the doubt that the oxidizing agent is the permanganate ion. And which one got reduced? Well, it's likely going to be the manganese. And I'm just going to double check. I already calculated in the previous problem that manganese is in the +7 oxidation state. And here it's going to be in the +4 oxidation state because we have 2 oxygens in the -2 oxidation state. So it goes from +7 to +4. The permanganate got reduced to manganese dioxide. Now it's a matter of checking which one got oxidized. Iron starts out in the 0 oxidation state and ends up in the +3. So if it goes from 0 to +3, it got oxidized. And if I were to identify the reducing agent, then whichever reactant got oxidized, that has to be the reducing agent. Hydrogen starts out in the +1 oxidation state and ends up in the +1 oxidation state. because oxygen is in the -2 state. So with that, we essentially identified all the requirements from this problem. In this chemical equation, we need to identify what component, what reactant got oxidized and which one got reduced. So as before, I could likely guess that this one is the oxidizing agent. And let me just double check. If there is a positive charge here, and we have two oxygens with a -2 charge, then we're going to say that this vanadium has to have an oxidation number of +5, right? Because +5 minus 4 will give us that +1 charge. And in this case, if we have one oxygen in the -2 charge, and it needs to add up to a +2, then vanadium is going to be in the +4 oxidation state. So if vanadium goes from +5 to +4, it got reduced. And if it got reduced, it's going to be the oxidizing agent. So this is correct, and this is correct. Now it's just a matter of the other one. If we know that the vanadium dioxide ion got reduced, then the other element, in this case most likely zinc, had to be oxidized. So I would bet that the correct answer is option C, but let's double check. Zinc goes from the 0 oxidation number to the +2, and as it increases its oxidation number, it will signal that an oxidation happened. So zinc got oxidized from 0 to +2.